welcome back to my channel. Today we are going to solve the problem number 16, three-sum closest. So this question is no different from three-sum. We are given an integer array nums, have a length of n, at integer target. Find the three integers in nums such that the sum is closest to target. So this question is asked you about this. Let me put it in a whiteboard. So this point is the target. So we have another point 3 and another point result. So result is identified as an infinite. It can be a positive infinite or plus infinite or minus infinite. It doesn't matter. But this is defined by the result. The distance from the target to the result is very big. And there's another point, it is called 3. So later on I will use this 3 point. This 3 point is the sum of 3 numbers. So if this point to the distance of target is smaller than the target to the distance of result, so the result will be equal to 3. And the final result will be this result. So in this way, we can always find the smaller distance from the 3 to the target. But how should we find that? We will use 2 pointers. If we already did number 15, three-sum, I think you can think about this idea easily. So this is called intuition. It is from your past experience. It is not problem-solving skills, but it is just intuition. If you solve some problem from before, if you know the pattern and you know how to do it, you just need to change a little bit about the closest. So this is only the three-sum closest. Now let's get back to the code. I think if you see the code, you will think how similar it is to three-sum. First of all, we need to define 2 variables. So one is the result, another is n. The result will be, as I said, it will be infinite, and n will be len nums, the distance of nums. Then we can use a for loop directly for I in range n. And here we have 2 pointers, L and R. So the L pointer will be I plus 1, and R pointer will be n minus 1. Similarly to three-sum, so here will be the same, L less than R. We have a 3 equals to sum of the numbers. So inside it will be nums I, nums L, and nums R. So it's these 3 numbers. And the result here, from here we can check the result. We need to check a condition. If we've already got the 3, so the distance we need to use absolute. So the 3 minus, let me put a minus target less than the distance of result minus target. So because we use absolute, the target minus result and result minus target, it doesn't matter, it's just a distance. So if this distance is smaller, then the result would be equal to 3. This one I think I've already explained here. If this is 3 point to here, the distance is smaller. So the result would be here because this one is the closest point. If you find another point that is even closer than this 3, so the 3 will be this result would be here. If here is another result is here, so the 3 result would be this 3. Yeah, so we need to find a lot of different 3s, so the result will be the closest, so the result will be equal to 3. And how we should find that? We use 2 conditions. It is 2 pointers condition to check that. Here we don't need to prove that because we've already solved a lot of problems. So in this way, actually we can find if if 3 less than target, it means the left pointer should shift by 1, else the I pointer should minus by 1. And next, we can return the result. Now let's check if it works. So here, y, it is L plus 1, because here, if 3, let me draw something. So here, this is because our, I didn't, we should sort the numbers. Nums dot sort, yeah. If we sort the numbers, it will be a line like this. It's an increasing line. So if there are 2 points, this one and another one, if the sum of them is, imagine here is the target. If the sum of them, yeah, the target may be another value, maybe 5 or something, 5 or 10. Yeah. If the sum of them is smaller, it means this left pointer should shift here, because when it shifts here, it might be equal to this number or get close to this number. Yeah. If this point this point is bigger, if they were to get closer, the right pointer needed to shift from the right to the left side. I think here should be clear. Now let's run it to check if it works. Yeah, it works. Now let's submit it to check the speed of the algorithm. Yes, it works, and the speed is a little bit slower. As I said before, when we use the threesome, we can speed up a little bit. Here, we can also try to speed up a little bit. So we need a if condition. If I more than 0 and nums I equals nums I minus 1, we need to continue. We don't need to check. Yeah, because here doesn't influence our algorithm. It's basically the same. Now let's submit to check if we can increase the speed a little bit. Yeah, because here it's an outer loop. It should increase a little bit. Let's check. Oh, it didn't. Yeah. But it's okay. I think this algorithm is still okay. The time complexity is O(n) log n. Yeah. I'm sorry. The time complexity is O(n) because here this areas takes place because here is one loop. Here is another loop used 2 pointers. So the time complexity is O(n) square. Thank you for watching. Bye. See you soon.